The figure shows a graph of the function of f of x in the xy coordinate plane. The function g is defined by g of x equals 2x minus 3. So here we're comparing f of x, which is on the graph, with g of x, which is an equation, a linear equation, and we're comparing it with a quadratic function. Which statement is true? A says f of 0 is less than g of 0. So I always like to figure out the number and write it above the place where it says that, value, like where it says f of 0, I want to write the actual output next to that so that I could compare easily. So f of 0 means look for a 0 on the x-axis and find the output, and that would be right up here, 0, 7. So the output is 7. G of 0, well, here I'm using the equation, so I'm taking g of x and I'm putting in 0 for x. So instead of 2x, I'm writing 2 times 0 minus 3. And if you go ahead and solve that, 2 times 0 is 0. Minus 3 is negative 3. So if I look at that statement, it says 7 is less than negative 3. That is not true. Let's look at choice B. F of 1 is less than g of 1. So I'm looking at an input of 1, and that gives me an output right here, somewhere in between 3 and 4. My students estimated about 3.75. Okay, for f of 1. And we're looking at g of 1. So we're putting 1 into the equation. And we get 2 times 1, which is 2, minus 3, and that is negative 1. So now it says 3 3/4 is less than negative 1. Still not true. Cross it out. C, we're comparing f of 3. So we look at 3, and I see the point 3, 1, output of 1. Then I take the equation, I put in g of 3 is 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. And here we go. 1 is less than 3. Yes, that is true. So it's choice C. One other way you could have done this would have been to put this on a graph. So say you had negative 3 right there, and you go up 2 and over 1, and up 2 and over 1, up 2 and over 1. So you're just kind of checking which one is higher at each value. You could have done that as well.